Okay, so let's solve some equations. The addition property of equality tells us that for all real numbers, a, b, and c, if we have an equation in which a is equal to b, then we can add the same number to both sides of that equation without changing the equation itself. So let's start doing this using algebra tiles. The nice thing about the algebra tiles is that they take something that is a little bit abstract, like algebra, and they make it a little bit more concrete. So we'll start by grabbing an x tile and two 1 tiles and putting them on the left side of the equation. The bar signifies the equal sign, and we'll put 5 1 tiles on the right side of the equation. So the positive x tile is denoted by this green tile. When you're ready to make a copy, you click on the tile itself, and you want to make sure that the tile is chosen, not the text portion of the tile. So when you get a nice solid box instead of a dashed box, you know the tile is chosen. There are several ways to make a copy. You can right-click on it and copy it. You can type Control with a D to duplicate it. Or, I'm going to undo that by doing a Control Z. You can hold your Control key down while it's chosen, and notice that you get a little plus sign with your arrow. That means that you can copy it, drag it, and drop it. So there's our X. We'll add 2 1 tiles. Notice I have to make sure the tile is chosen again. Grab a couple of those. And then we want to have 5 1 tiles. I'm going to press the Shift key here and grab this one as well. Then my Control key will copy 2 of them at a time. So I'm saving a little bit of time here, because I want 5 total, so I only need 1 more. The tile itself, not the number that's associated with it. And I have modeled the equation x plus 2 equals 5 using the algebra tiles. Now that addition property of equality says that if I want to solve this equation for x, I want to get the x all by itself and remove the 2 that are with it. So to do that, I want to take away 2 from this side, or create 0 pairs so that they can be removed properly. To do that, I'm going to grab 2 copies of this -1 tile and put them on the left side of the equation. But when I do that, I have to also balance it out by adding that same number, a -2, to the other side of the equation. So I'll hold my Shift key down to select them both, Control key down to make a copy, and I have not impacted the actual value of the equation, have not changed the equation itself, just its appearance. So the next thing we'll do is rewrite the equation or make copies of what's left over. These 0 pairs will cancel out. We'll be left with an x on the left-hand side, and we will be left with 1, 2, 3 1 tiles on the right-hand side. So in this particular equation, x has a value of 3. For our next example, we're asked to solve a minus 4 equals 2. The nice thing about these electronic algebra tiles is that if we're now asked to solve for a, we can change the label of the tiles to be an a and a negative a. So if we're asked to solve a minus 4 equals 2, we go grab a positive a tile. And we want minus 4, so we need 4 of these -1 tiles. Control D duplicates. We can move them over if we choose, or we can leave them in a staggered appearance. And then on the right-hand side of the equation, on the right-hand side of our bar, we need a positive 2. So we copy 2 1 tiles over. And we've modeled this equation now using tiles as opposed to strictly the variables and numbers. So the next step is to say I want to isolate my variable. I want to get the a tile all by itself. And it has 4 -1s associated with it, so the opposite of a -1 is a +1. So we'll go grab the positive 1 tiles. We need a total of 4 to balance them out. But whatever we do to the left side of the equation has to be done to the right side. So we need to put 4 positive 1 tiles on the right-hand side. And we have not changed the equation, just its appearance. Now the 0 pairs will cancel out. So our result will be A on the left side of the equation and a total of 1, 2, 3, 4, 5, 6 1 tiles on the right-hand side of the equation. If it makes you feel better to move those two so they're in line, hold the Shift key down while you click on them, so you can choose 2 at a time, and our result is A equals 6. For our last example, we're asked to solve -1 equals 3 minus x. So we grab a -1 tile and put it on the left side of the equation. And then we need 3 1 tiles, positive 1 tiles, on the right. And we need a negative x tile on the right as well. So once again, we're trying to isolate the variable. It has 3 1s with it. To get 0 pairs, we need 3 -1s on the right side. But if we add 3 -1s to the right side, we must do the same to the left side. Holding the Shift key down, I select all 3. Make a copy. And my net result is a -4 is now equal to, these are gone, -x. So if the opposite of x is a -4, what will x be? +4. And it's perfectly fine to write 4 is equal to x, or x is equal to 4. They are the same thing. So now that we've worked the equations using algebra tiles, let's work them out algebraically. Again, solving x plus 2 equals 5. We want to isolate the x and get it by itself. So to do that, if 2 is added to it, we want to take away 2 from the left-hand side of the equation. But if we subtract 2 from the left-hand side, we have to be fair to the right-hand side and take away 2 from the right-hand side as well. So when we do that, we're left with x on the left-hand side, and a +5 minus 2, or +5 plus a -2, gets us 3. Reworking our second example using pencil and paper, we're solving a minus 4 equals 2. Isolating the variable, getting the a by itself, it has a 4 subtracted from it. The opposite of subtraction is addition, so we need to add 4 to the left-hand side and be fair to the right-hand side by adding 4 to it as well. Now we add them up. A minus 4 plus 4, 0 pair, gone, equals 2 plus 4 is 6. Same result, just different methods. One very visual and one a little bit abstract. Here's our third example, solving -1 equals 3 minus x. We want to get the x by itself. It has a +3 next to it, so we'll subtract 3 from the right-hand side and subtract 3 from the left-hand side. -1 minus 3 is the same as a -1 plus a -3 for a total of a -4. And that's equal to not a positive x, but in this case a negative x. So if the opposite of x is equal to a -4, then x must be a positive 4. And if you prefer to have your variables on the left-hand side of the equation, there's nothing wrong with switching that. X is equal to a positive 4. If you want more practice with Algebra Tiles, visit systree.com. It has example student worksheets for you to download and then you open up in Microsoft Word and use the same process that we did here.